Okay, so I got a question from a student, and this is the question. She said she was working on this and she wants some help with it. So let's talk about this together. Let me just read it out loud, and then we'll sort of analyze it. We'll take some notes and analyze it. Excuse me. The fuel used in many disposable lighters is liquid butane, right? C4H10. Okay, so let me write that down. C4H10. Right? Okay. And butane has a molecular weight of 58.1 grams in 1 mole. So we're playing a big ratio game here, right? So let's make some notes about the C4H10, and then we'll say something about the grams per mole. There are 4 carbons, atoms, for every 1 molecule of butane, which I'm going to write as C4H10. Okay? There are 10 hydrogen atoms, right, for every 1 molecule, right? Well, those are a couple ratios. Now let's look at the next ratio that's given to us, and that is 58.1 grams in 1 mole. So this C4H10 has a mass, a formula weight. Let me say molecular mass, molecular weight, because I think that's going to sit in your head nicer. Molecular weight, 58.1. Watch this, grams per mole, right? So that's the first thing. All right, let's write down another ratio here too. We've got these ratios here. 1, 2, and here's another ratio, grams per mole, right? Grams per mole, okay? Let's write another one down. Since I see moles there, I'm going to need this. There are, for every 1 mole, there are 6.022 times 10 to the 23rd particles, right? Actually, let me write that in blue. Probably a better way to erase than that. 6.022 times 10 to the 23rd particles, right? Or pieces, or molecules, right? There's another ratio, okay? And then, by the way, let me put another ratio in here which may help you understand this molecules and moles things better. Did you know that for every 1 dozen, there are 12 cookies, right? You could also say 1 dozen would be 12 eggs, right? It would depend on the conversation, right? So there's a bunch of ratios there that we're concerned about. Now that we've got that, let's go back up. We've made some notes. Let's go back up and look at the question. The question is, how many carbon atoms are in 4 grams of butane? All right, so we got a mass here. Mass is equal to, oops, I want that in blue, just to keep things clean, right? 4.00 grams of butane, right? 4.0 grams of butane. So the question was, how many atoms? So what I'm going to do is I'm going to come down here, and I'm going to lay out the problem, and I'm going to say equals. No, let's don't do that in blue. I'm really trying to get a good system here for colors. So we'll put all of our numbers in blue, okay? Now, if I'm working out some problem and the answer is going to be in atoms, I got to take all my ratios up here, and I got to have atoms in the top, right? So because this is the numerator, right? So this is atoms, and the question was how many carbon atoms, all right? So this is going to be carbon atoms. And so I got to look up here and see what ratio has got carbon atoms in it. And I see, aha, there it is right there. There's my ratio with carbon atoms in it. You see it? 4 carbon atoms per 1 molecule of butane. All right, so let me say atoms per, let's see. Looks like this is related to molecules of butane, right? So I'll put the numbers in just a minute. Let's get everything laid out first, okay? So here's my atoms. My atoms is here. And so far, so good, but I got to cross off molecules somehow, right? So I'm going to come back over here, working on my colors. Molecules, can you read my writing? Molecules. And let's look back up here and see where molecules is. Okay, well, there's molecules in here. There's molecules in this ratio. There's molecules in this ratio, but that relates it to hydrogen atoms, and I don't care about that. We're talking about carbon here. Aha! Here's molecules. Look at that. So it looks like molecules is related to moles there, right? So let's come over here and say molecules to moles, right? And it looks like that's molecules of butane, C4H10. This is C4H10 also, right? Molecules of butane. Sure, perfect. Those cross off just great, right? So let's come here. Those will definitely cross off. But I've got moles here, so I've got to cross that off. So let's write moles. And let's come back up here. Okay, I've got moles here, right? But I've already used that ratio, so I can't use that one. I've got, moles. Moles is related to grams here, right? You see that? So it looks like moles is related to grams. Okay. And we'll write the actual numbers in just a minute. Moles are going to cross off nicely. Okay. But it looks like I've got to get rid of grams. Okay. Oops, I want to put that in yellow. Moles are going to cross off nicely. Okay. I've got to get rid of grams. Well, aha, here it is. Look at that. Here's my grams. Okay. So I think I'm ready to put all my numbers in. Those will end up crossing off, right? Those are going to cross off. Let's put all of our numbers in, multiply everything out, and see what we get. So this is 4.00, 4.00, and then the grams per mole. Where would that number? Aha, okay, that was up here, 58.1 grams per mole, 58.1 grams per mole, right? And it looks like molecules and moles are related. So it looks like molecules is 6.022 times 10 to the 23rd. 6.022 times 10 to the 23rd molecules per 1 mole, right? And then the atoms, looks like there were 4 carbon atoms. 4 carbon atoms for every 1 molecule of butane. So this is a little bit messy. What I'm going to do now is I'm going to come down here. I think I'm done. I'm going to go to white. Looks like I got 400. I took care of that. Now, the 58.1 is in the denominator, right? 58.1, took care of that. This is just a 1 up here, so I'm not going to worry about that. 6.022, 6.022 times 10 to the 23rd, took care of that. And it looks like there's a 4 here. I'll take care of that, times 4, right? And there's a 1. I don't care about that. And that's also a 1. So this looks like this is my answer. All my units are crossed off except atoms. I'll put that back in red. Atoms is equal to atoms, right? So let's put those numbers in there. I'm going to come over to my calculator, which looks a lot like a computer. 4 times 6.022 times 10 to the 23rd times 4 divided by 58.1. And that is going to get me 1.66. 1.66. 1.6. Let's do that in white. 1.66 times 10 to the 23rd atoms. 1.66 times 10 to the 23rd atoms. And that is my answer. Okay, so in review, what I did was when I read this question, I made a bunch of notes on all the ratios I had here. I know when I'm asked for a particular thing, in this case atoms, I'm going to have to cross everything off except atoms, right? So I wrote down all my ratios. Atoms to molecules. Let's go back here. Atoms to molecules, right? I have another ratio over here which I never used because that was asking about hydrogen, right? And I got another ratio, my molecular weight, 58.1 grams of butane for 1 mole. And that's a ratio there, 58.1 grams per mole. And I used this one just to remind you that you're okay with stuff like that. 1 dozen is 12 cookies, right? Just to sort of demonstrate a ratio. And then I got another ratio. Aha. Moles per molecule. Okay? And then finally I had a measurement here, 4 grams. So if I had 4 grams, here's my 4 grams over here. If I have 4 grams, how many atoms is it going to be? And I just used a bunch of ratios to cross that out. To cross off the units, and really it's essentially conversions. All right, so I hope that's helpful. We'll do many more of these this semester. This is probably the most important skill that you'll get this semester in chemistry or physics. I know we're doing chemistry, but it's the same thing we do in physics. All right, good luck.